So Python provides two different ways to loop around a block of code with for loops and while loops. Now we've seen how a for loop can be used to iterate through an iterable, so either the items in a sequence or the numbers in a range. But sometimes we actually need to keep looping as long as some condition is true and then stop when it becomes false. Now we do this using a while loop. So the basic format of a while loop is just a while and then some condition, colon, and then we execute a block of code. So let's just look at an example of a for loop that we've done earlier in this section and then contrast that to a while loop. So we'll start off by typing for I in range 10, print I is now, use a replacement field dot format I. Then we can run that. Again, we've seen that code in this section. Nothing new there. I is now 0 through to 9, as you can see, because we've used the range 10. So that's a for loop. Now with a while loop, we can produce the same result. So what we can do is I'll just comment that code out. And we can do something like I equals 0, while I is less than 10, print I is now, same thing, same replacement field, dot format I, and then I plus equal 1. So if we run that just to confirm that's the same, we get exactly the same result that we got in the for loop. Now you probably wouldn't use a while loop just to iterate through a range of values like we've done here, but this does give you a good example to see what's actually going on. So the first thing to note here is that the condition on line 4, I less than 10, well that controls execution of the block of code in the loop, which is the code on lines 5 and 6. So in other words, as long as I is less than 10, the code on lines 5 and 6 is going to be executed. But once I becomes equal to or greater than 10, the condition becomes false and the loop terminates. In other words, there's no more processing. And you saw that because we had I less than 10, I is now 9, and then it automatically skipped at that point, and that was the end. But this leads to two other important points to consider here. Number one, first, the condition must be initialized before the loop starts. And you saw me do that on line 3 when I initialized I to the value of 0. Now with the for loop, of course, we just use I without setting a value first. And that's because Python knows to give it the first value from the range and to continue from there. But with the while loop, we had to give I a value first. So if we didn't, we'd get an error that I is not defined. So that's another distinction that you'll have to do when you're using while loops. But the second thing that is important here is that we need some way within the loop for the condition to become false. So just to show you what I mean, if we remove this, remove the indent to put that back to the left-hand side so it's no longer indented, and if we run that, you can see we've got a loop here happening on the right-hand side. The code's never been executed, and I'll just stop that. You can see there was no way for the condition to become false. So in other words, there was no way to exit because I was never being incremented. So this condition could never, or this condition forever would stay true. We'd always have I being less than 10 for that situation. And you saw on the example here to the right that I was always 0. So consequently, we could never have a false condition. So the loop just kept looping infinitely. And just out of interest, if we wanted to do that, we decided we wanted to loop infinitely. We could have just done while true and done something like that and run it. We would have achieved the same results you can see there. But I'll stop that now. Now, there are some scenarios that you'll see loops that just use true as a condition, but the body of the loop then contains a way to break out of the loop. Now, you can see that in this scenario, and I'll just undo this so we go back to the example we had that was working, fix the indent. So you can see why a for loop is preferable in this particular case, and it'd be very rare to see a while loop used like that because frankly there's more work, there's more code. We've effectively got 4 lines of code there doing what 2 lines of the for loop did on lines 1 and 2. But there are many reasons for looping around a block of code that don't involve just going through items in a sequence, which we did in this case. So for example, in an adventure game, players have to choose a direction in order to exit from a location. Now, if they don't choose one of the available exits, they stay where they are. Now, that's an ideal use of a while loop. So let's do something for that like that. So we'll just comment this code out. And we could say something like available exits equals east, northeast, south, chosen exit equals, and then we'll just initialize it with an empty string. And we can put while chosen exit not in available exits. Then we'll put chosen exit equals input. Please choose a direction. And then on the next line, we'll change the indent level. Print, aren't you glad you got out of there? And fix a bracket at the start. So just to confirm that, we'll actually run it. Please choose a direction. We could put something like north. Please choose a direction because it wasn't in the available options. You can see on line 7, we've got 3 options there, and we type something like south. Aren't you glad you got out of there? So the interesting things about this is we initialized the variable chosen underscore exit on line 9 to set it to an empty string. And so that meant that the first time we started the while loop, chosen exit wasn't in the available exits, so therefore it was able to go through and ask what the direction it was. If we had initialized that variable to east, let's say, and run this, you'll see that the loop didn't even get processed at all because the first condition, while chosen exit's not in available exits, well, that returned false. In other words, chosen exit was in available exits, so consequently this line of code was skipped altogether, that we just got this printout there. So we've initialized it now on line 9, and then it's going to keep looping effectively until we've got a valid input. In other words, the exit that we've chosen is in the list that we've defined on line 7. So probably the most important feature, or certainly one of the most important features of while loops, is that they can be used in this scenario, and that's where you can't determine in advance how many times you actually need to loop. So a for loop will repeat for each item in a predetermined sequence, whereas as you can see here, a while loop, you don't need to know ahead of time how many times the loop will execute. Because of course in this scenario, this could continue sort of hundreds of times until the player typed in a direction that was in our list on line 7. So one particular application of this would be reading data from a file. Now it's difficult, although not impossible, but certainly difficult to know in advance how much data there is to read from a file on your computer. Now the while loop can be used to keep repeating until there's no more data left. Now we'll see this soon when we look at file input and output, which is in a future section of this course. But let's just enhance our example a little bit, because just like with the for loop, we can also use break and continue to break out of the loop or to cause the loop to stop the current iteration and then to test the condition again. So a break statement can provide a simple way to quit, in other words, without choosing a valid exit. So what we could do there is we could do something like if chosen exit is equal to quit, we could do print game over break. Now if we run that, we've still got scenarios where if we enter something wrong, like west, that's not going to work. But if we type quit, you can see game over was printed out, and then we exited the game with the break. So the break exited out of the while loop in that scenario. And again, we just run it again to confirm it still works with a valid one, east, and that still works, as you can see. But we probably shouldn't print the final message if the player chooses quit though. So just like a for loop, we can also use else in our loop. Then you saw that in the for section. So in other words, down here we can put else. And this is only going to be executed just like with a for loop if the code hasn't been broken out of, in other words, a break statement hasn't been processed. So if we run that, and again we'll type quit. Oops, I put a space there, quit. We've now got game over, and you can see that because of the else, the statement wasn't printed, and we can just put a valid one in. If we put east, we should find that does actually show that message on the screen. Aren't you glad you got out of here? Now, in the earlier lecture on if statements, if you recall, we created a very simple guessing game, and that's where the player had to guess a number between 1 and 10. Now, there were a number of problems with that game. One problem was that it only allowed 2 guesses, and if we wanted to allow more than 2 guesses, what we had to do, what would it involve would have been nesting more and more if tests every time they guessed incorrectly. And the other problem was that 5 was always the correct number, which makes the game a bit boring. Not that, of course, it was terribly engaging to begin with. But the first problem we talked about there can be solved using a while loop. In other words, if we want to allow more than 2 guesses. And you're going to be doing that in the challenge next. But before we do that, though, let's digress slightly and address the second problem to produce a more interesting game. And that's, of course, whether resolving the situation where the correct number to guess was always 5. So to fix the problem of the correct number always being 5, what we need to do is get the computer to generate a random number in the chosen range. So 1 to 10 in the example of this game, but of course we can extend that. Now Python's got a lot of features built in, such as the ability to do arithmetic, lists, ranges and tuples, and of course more than that. And you've seen a lot of that already as we've gone through the course. And in fact, lists and iterators, etc. you're going to be dealing with in the next section. So there's enough built in fact, for us to be able to write a random number generator if we wanted to do that ourselves. But the great news is that one's already been written for us and ships with Python in a module called Python. So we're going to be looking at creating modules and packages much later in the course. But for now, what we're going to do is use the one that comes with Python. Now, because it's an external module, we need to import it into our program using the import statement. Now, don't worry too much about this now. All you really need to do, or all you really need to know to use it, is that we have to import it first, which tells Python which location to go to grab that particular piece of code so that we can actually take advantage of that and use it in our game. So let's now go ahead and type in that game. I'm going to comment all this code out again. Like so. So instead of typing it out, let's just go ahead and I'll just paste this code in here first, and we'll go through it because it's essentially exactly the same as the previous game with a few extra lines of code. So you can see what I've done there. So we've started off, we've got import random. So that's the command which tells Python that we want to take advantage of this pre-written code to generate random numbers. And you can see on line 21, well, firstly, we're starting with the highest. We've defined a variable called highest, which is set to the value of 1. And on line 21, we've got the answer, which is a random number between 1 and the highest number, which is in this case 10. So in other words, answer should be a number between 1 and 10 each time. And you can see that we've now modified the program slightly to also display but the number. Please guess a number between 1 and we can put the number in however we wish. At the moment it's set to highest. And what that means is you could change this number if you wanted to make that sort of 20, 50, 100 or whatever you wanted to do. And then we've got the code which is essentially the same as what it was before going through that guess scenario. But of course that's still a little bit limited in that it's only going to give us 2 chances to try it, and probably in most cases you'd need at least 4. So let's just try running this to confirm that it works. Please guess a number between 1 and 10. Well, we can try 5 first. Please guess higher. We can try 8. Sorry, you've not guessed correctly. We'll try again. And of course, it didn't help us because it didn't tell us what the number was either. We'll try again and see whether we can just fluke it. 5 again. Please guess higher. We'll try 8 again. Sorry, you've not guessed correctly. We'll try one more time. 5. Lower this time. We'll try 3. Sorry, you've not guessed correctly. Okay, so you can see that the point is that that number has now changed anyway. We had 2 times it said the number is higher. The second time it was lower, so clearly it is generating a random number each time. But of course, the game as it exists is very frustrating. And the reason that it's frustrating, of course, is that we've only got 2 chances. So what we probably need is a minimum of 3 or maybe even 4 guesses to be sure of getting that number correct. So that's going to give us a good challenge to try. And so what we'll do is we'll look at that challenge in the next video.